Hey, welcome back. Today's objectives are to identify, name, and draw molecules containing the thiol functional group, and recognize and predict products for reactions involving thiols.
First of all, what is a thiol? If you're going to name these things, you got to know how to find them. I always like to introduce these by comparing them to alcohols because they're pretty similar. Sulfur atoms have really similar bonding properties to alcohol. So if you think about the oxygen right here that would have made this molecule an alcohol, and imagine replacing that with a sulfur atom instead, you get a thiol instead of an alcohol. The general formula for these is, of course, an SH, the R group representing any group of carbon atoms that it is attached to.
Alright, thiol naming rules. It's going to look a lot like the alcohol naming rules with one minor change. First, we're going to find the longest carbon chain. In this case, we have 2 carbons, and we're going to name that with the backbone. So we have ethane, and then the thiol is coming off the first carbon. So all that you do for this one is put the number where the thiol is, add the backbone, which is ethane, and then you just write the word thiol after it. Pretty simple, pretty straight to the point.
Here's a slightly more complicated example. First thing you do is find the longest chain with the SH attached. There it is. We're going to number that from the end closest to the SH group. That's going to be the right hand side, so 1, 2, 3, 4, right to left. We can now name the parent chain as 1-butane thiol. The 1 tells you the carbon that the SH is attached to. We also do have some attached groups on here, a methyl group coming off of carbon 2, so that's of course a 2-methyl, the final name being 2-methyl-1-butane thiol.
Alright, so we're going to get into a more complex thiol. Notice that J Rocket says thiol, I say thiol. It's tomato. You know, he's from a different part of the world, being North Jersey, and I'm from, Pennsylvania. So let's get into the thiol naming. The first thing you're going to do is you're going to find your longest carbon chain. You're going to number it. So we have 8 carbons in this chain. We're going to name that 4-octane thiol. Remember that the 4 is where the thiol is coming off of, and the ending, you just put the word thiol after it. We still have one group hanging off of that, and it's a benzene ring. Remember, if the benzene ring isn't our longest chain, we're going to call it a phenyl. We're going to address it by the number 5 because it's the carbon that it comes off of. So we have 5-phenyl 4-octane thiol.
Okay, for our final naming example, we have a benzene ring with 2 thiols coming off. A lot of times benzenes with groups attached to them get special names. For whatever reason, thiols don't have any kind of special benzene name, so the backbone for this, the parent chain, is simply called benzene. Nothing weird to worry about. We're going to number these 2 things. They technically get numbers 1 and 2, but you got to remember, if any time a benzene chain is di-substituted, like it is right here, we're going to use O's, M's, and P's instead of numbers. Since the 2 groups are right next to each other, that is the ortho configuration. So our final name is O for ortho, benzene for the parent chain, and dithiol. Notice di, you have to put that in there anytime there's 2 of anything.
Let's take a look at the reactions of thiols. The first one is oxidation of thiols. We have 2 thiol molecules that react and attach to each other at the sulfur atoms. So there's our 2 sulfur atoms, with otherwise known as a thiol right now. And we're going to add any oxidizing agent to that. And what's going to happen is the 2 thiol molecules are going to attach at the sulfurs. Notice that both of these sulfurs have hydrogens that are attached to them. Those 2 hydrogens are just going to get kicked off into solution or broken off of those chains, and they're going to go away. And that can happen because we make that extra bond in between both of the sulfur atoms. And this is called a disulfide anytime you bond 2 sulfur atoms together.
So this second reaction is a similar reaction, but this time with heavy metals involved. Heavy metals, if you don't know, pretty much lead and mercury. Pb is lead and Hg is mercury. What happens here is 2 thiol molecules, there's the 2 of them, they react with each other with a heavy metal atom such as lead or mercury. And it's going to do pretty much the same thing as the last example. These two molecules, the hydrogens are removed and the sulfurs attached to each other, except this time there's a heavy metal atom which ends up in between the two S's. So the Hg or the Pb is going to go right in there. So your product for these is always going to be very simply the two molecules, S's pointed towards each other with the heavy metal in between them. Just as a side note here, this is the reaction that makes heavy metals like lead and mercury so dangerous for people. This reaction happens with proteins in your body, which messes up the function of those proteins and makes you very sick in a lot of different ways.
Our last reaction for thiols are acidic reactions. And this is when we take a thiol and we're going to pop off the hydrogen in solution, which is water, and it's going to make an H3O, which is a hydronium ion, and it has a positive charge. The more hydronium ions that are in solution, the more acidic that solution is. What that's going to do to the thiol is it's going to basically make the thiol seem shorted. It's going to want that hydrogen back. But since it's popped off, it's going to give that thiol kind of the rights to want another electron or want another hydrogen to come there. So it's going to have a negative charge there, -1, which is that same hydrogen that just got attached to the water molecule. So this reaction, what it does is it just makes a stronger acidic solution when dissolved in water.
Alright, so to close it out here, we have some examples of where you can find thiols in everyday life. These things are best known for their very strong smells, which are pretty unpleasant and similar to rotten eggs. If you've ever smelled a skunk before, what you're really smelling is a complex mixture of several different thiols that the skunk actually produces inside of its body. Here's just 3 examples of some of the thiols that are inside of skunk spray. Humans also use thiols by adding them to flammable gases such as natural gas and propane. If you've ever smelled these things, they have a definite odor and it's not very pleasant. The reason we do this is because if there's ever a gas leak, people need to know if there's a gas leak. So by adding a small amount of thiols, you can be aware of the leak and get it taken care of before it causes any damage.
The objectives for today were to identify, name, and draw molecules containing the thiol functional group. Just remember, you just add that thiol to the end of the root. So if you have a 2-carbon thiol, it would be ethane thiol. The other thing that we went over today is how to recognize and predict products for reactions involving thiols. We are now starting to collect multiple reactions, and you need to be remembering how these reactions work, and you have to memorize these reactions. You don't want to be trying to cram all these reactions into one study day before the test, so make sure that you're keeping up with the reactions. If you have any questions, you want to go over any of these reactions or problems, just bring those questions to class.